to start. There we go. There is our recording. All right. So do remember that live lessons are not optional as much as some people may think they are. I'm saying this on the recording very intentionally because we need you to be here in class to learn. There are only 28 of you in here this morning. We're starting a tad early, but that is I'm by like a minute. So make sure if you are watching the recording is like a option for like if you're sick or you have a doctor's appointment, etc. Not like, hey, I just want to sleep in and don't want to make my 8:00, 8:30 biology class a normal thing in my life. So that's all I'm going to say about that. Welcome to biology. We are getting, what did I tell you about the content that we are in right now? Easy or hard? Easier here. Easy or hard? This stuff is getting hard. Okay. This stuff is getting hard. So it's going to require your focus. It's going to require your attention. It's going to require some study on your part, not just here in class, but outside of class. So please be sure that when you are here, you're engaging. All right. Not just with your classmates, but with me. All right. And the content. So with that said, I'm going to continue to leave chat on. I just want to make sure we stay focused in chat. We've had some teacher meetings and they're like, I don't want to be a mean teacher. I don't want to discourage conversation, but we have to stay on task and I don't want them to fall behind because they're not focused. So we've been talking about turning chat off, turning microphones off, just so that we get focused. So, all right. Yes. So if you can stay focused in chat, then we can keep it on. All right. As I said to those of you that were in here earlier, please go ahead and grab a jar of Play-Doh. This is a large Play-Doh jar. Maybe you don't have a large Play-Doh jar like this, but a typical size or even a little bit of slime would be a fun thing to grab today for our lesson. So if you have some Play-Doh at your expense, I do think this is Ren's Play-Doh jar. I believe Santa brought this to her last year. Oh, I don't know. Mila says I got it for her birthday. I don't know that I did. But, ooh, yes. Ari has a lavender scented Play-Doh. That's awesome. Slime, Play-Doh. I'm trying to think of anything else that reminds me of something this texture. Oh, I know. If you have a jar of crescent rolls or biscuits in your refrigerator. There you go. All right. I can't say that that will be as fun as Play-Doh, but it would have the same consistency. All right. With that, go ahead and grab those and then get back to your computer. We are going to start our lesson on the cell cycle today. So I would like anyone to get on the mic today. Is there anyone new that would like to pop on the mic today? Anyone new? Any new voices?
As Miss Jackson once said, don't be shy, as she once said.
Oh, you're the youngest in your house, Riker. I understand that. Oh, that's awesome, Maria. Anybody else want to? All right, so let's go ahead and have Pip read the first 3 and Aria read the last 2.
All right. So what is mitosis? What are the phases of mitosis? And what is meiosis? Thank you.
All right. And Miss Aria.
Able to write the difference between mitosis and meiosis? And why is meiosis important for reproduction?
Good, thank you. Awesome. Great job, ladies, reading that for us. So we are going to talk about mitosis. Everybody say it. Mitosis.
Mitosis.
And meiosis. Meiosis, mitosis and
Meiosis.
meiosis. They sound the same and they are a lot the same, but there is a big difference at the end. All right, so again, you can see we're starting down here at knowledge. And by the end of, I would say tomorrow, these are going to be our goals for today and tomorrow. By tomorrow, we're going to be up here more in our application and our understanding. So we're going to start down here and then build our way through our understanding of what mitosis and meiosis is. So to start out what this is, we're going to look at the cell cycle. All right, the cell cycle kind of reminds me of like your day, all right? Your 24-hour day. So what's the first thing you do when you wake up? What's the first thing you guys do? Get up, get dressed, use the restroom, brush your teeth. I literally think maybe the first thing I do is grab a cup of coffee. Maybe that's what I really do. Is that sad? Before I even do anything else? Look at your phone. Yes. Stop my alarm and chill for a minute. Yep. Scroll through those phones when you wake up. Good. So then we get to what? We start maybe our class cycle. We get to start your day with me. And what a better way to start your day, right? So we start class, we start biology, and then you go through your school day, right? So every hour or so, you have a different high school course. What do you do with your afternoons? What do you do with your afternoons? Eat lunch, make lunch, do homework, finish work, read, play on your tablets, complete your assignments, and eat your lunch. Good. So then it gets us to late afternoon, evening. What do you guys do in the evening? Text your friends and your family, go to work or practice, work out. I like this. Good. So then do you have a like nighttime routine? Maybe you don't. Does anyone have a nighttime routine like before you go to bed? Is there like a show you watch and then do you have ways of winding down, take a shower, listen to music? Pip just lays down and passes out. That's awesome. Play computer games, play your guitar. Love that. Aw. FaceTime your girlfriend. Oh, don't sleep at night. That's hard. All right. Well, just like you have routines in your day, all right, the cell has a day too. All right. And if we looked at a day in a life of a cell, this is what it would look like. All right. It might get up, it's going to grow for 9 hours. Then it's going to replicate its DNA. Then it's going to prepare for division. And then in this very short 1 hour window, all right, it's going to divide. So we're looking at 9 hours, 10 hours. We're at 19 hours. Plus 2, 21. So out of 22 hours, only 1 hour of the cell's life is spent in cell division. Is that a lot of its time, a lot of its day, or a little of its day? It's not that much, right? It's okay, Cody. It's not that much time of its day. It's just a little bit of its time. All right. It's a little bit of time of the cell's life. However, it's a very important piece of its cycle. So sometimes what I think kids think about or students think about, or at least I did as a student, was that when we see the cell cycle, we just think that the cell is always doing this. All of the cells, if we could look at all of the cells on our body, they would not all be going through this process of mitosis. In fact, very few of them will, because most of them will be in that interphase site, in the interphase portion of their life. All right. All cells come from pre-existing cells. What is that? It's called the what? Cell. Yes, cell theory, right? Cells come from pre existing cells, and through their life cycle, they're going to mostly be an interphase. And there's going to be this 1 hour window when they're going through mitosis. And what mitosis is cell division. All right. Put mitosis equals cell division in chat for me. Mitosis equals cell division. Mitosis is cell division, and that's what we're going to talk about today. It's a very short window of time in a cell's life, but it is an important part. So most of its life, it's spent in what? Most of its life, if you could look into all the cells in your body, most of your cells would be in what we call interphase. All right? A few of your cells, we might actually catch them in mitosis. And if we're lucky, we might catch a few cells in the process of cytokinesis. Now, I am, when is glycolysis in the cell cycle? Is that what you're asking? So glycolysis happens inside the cell, in the mitochondria, all the time. All the time. All right. Especially like think about when you eat, Dustin. Your food is going to go and get processed, right? Glycolysis starts in our cytoplasm and then moves into the mitochondria, right? It's a part of cellular respiration. Glycolysis doesn't happen like by itself. I mean, it does, but it's a part of a process. So, can mitosis and glycolysis happen at the same time? Absolutely, because they're in two different locations of the cell. Okay. Yeah, good question. So you tell me, guys, if I had to tell you right now, and it was on a quiz question, what do you think cytokinesis means? What do you think the process of cytokinesis is? Let's go ahead and slice and dice that word. If you had to slice it somewhere, where would you slice it? Ooh, I like that. Cyto. All right, so let's slice it there. What is the word cyto and kinesis? What are those like make us think of? Good. Okay. I like where you're thinking. I like where you're thinking. All right. What does cyto remind us of? Let's start there. What does cyto remind us of? Cytoplasm. Cytoplasm. Good. So can anybody tell me what the word kinesis means? Kinesis. Ooh, that's a good guess. Lots of good guesses. So kinesis actually means movement. Movement. All right. So there's kinesis in my arm right now. There's a movement. So cytokinesis means the movement of our what? Cell cytoplasm. So what happens at the end of cell division is our cytoplasm moves and splits. All right, it's what makes the cells eventually divide into two, but it actually means the movement of the cytoplasm. Yes, good. Kinetic, right? Kinetic reminds you of energy. I like that. And it takes energy to move, right? Yeah. So we can use those cues to help us remember that. So interphase is the cell state. It's how the cell is most of the day. All right? Just like maybe for most of your day, you're dressed, you're awake, you're doing your normal everyday chores. All right. That is interphase. So then maybe what we'll compare the rest of mitosis to is maybe like your evening wind down process or your get ready for bed process. Even if you don't have like a typical thing, like I always watch one episode of this show, or I always read a book and then listen to 5 minutes of music, and then I brush my teeth, wash my face, put my pajamas on, and go to bed. Okay. Always at the end of my day, even if it's not super routine, I put my pajamas on, I brush my teeth, wash my face, maybe I'll use the restroom, and then I go to bed. Right? There's some things that I do at the end of the day that I don't always do in the middle of my day, right? I'm not going to be like, oh, I just ate some lunch. I'm going to go upstairs and wash my face. Does that make sense to everybody? Because let's start with something that makes sense. All right, something that makes sense is a pattern that we use in our day, but that we don't use every hour. I'm not going to brush my teeth and wash my face and change my clothes every hour. Okay. So we're there. Don't overthink it. There's things we do every day at a certain time because of the time of the day it is. All right. And that's kind of how it is in mitosis. So if you have Play-Doh, this is where I want you to get out your Play-Doh. All right. Let's do this together. And if you don't have Play-Doh, you can watch mine. And then maybe if you go to the grocery or the store or something like that, you can grab some Play-Doh and do this on your own. So there are stages of mitosis, just like there's stages of me going to bed. Just like I brush my teeth, right? Just like I brush my teeth, wash my face, change my clothes, and go to bed, right? Then there are stages of mitosis. Prophase. Prophase. Say prophase. Metaphase.
Prophase, metaphase,
Anaphase.
anaphase,
Telophase.
telophase,
And cytokinesis.
and cytokinesis.
All right, and tell me in chat, what is cytokinesis? We already learned what cytokinesis is. It is the what? It is the movement of the cytoplasm. Good. Good. So you're already one step ahead knowing the end process. All right, so this format of mitosis is how a cell gets ready to divide. Just like we get ready for bed every night, our cells, for 1 hour of their cell day, get ready to divide. All right. And this is what they do. Prophase. All right. Prophase. It is the very first step in cell division. All right. So maybe if you're a note taker, maybe you've got some markers out in a white piece of paper, you're going to put 1 in a color. Maybe you're putting it in purple, and then you're going to write prophase. Prophase. All right, so what happens in prophase, and you're looking at a cell that is a rectangle. If you see a rectangle shaped cell, what kind of cell is this? A plant or animal cell? What cell is? Yes. Plant cells are rectangles, animal cells are circles. So we're looking at a plant cell. Right here in the middle, this enlarged area is our nucleus. All right, so we're looking at an actual slide of an actual plant cell with an actual nucleus that is in the prophase stage. So, what happens in prophase is our nucleus is getting ready for division. We talked about the difference between eukaryotes, cells that we have, and prokaryotes. What are the difference between a eukaryote and a prokaryote? This is why we learned this before today. What's the difference between a eukaryote and a prokaryote? Whew, drop my plate. Eukaryotes have a nucleus, prokaryotes do not. Good. And what is so special about their nucleus and their organelles that is different in eukaryotic cells? They have a what? Ma. Me. Something bound organelle. What bounds our organelles in eukaryotic cells? Membranes. Yes, membranes. All right. Membranes are around each one of our organelles to protect them. So, what happens in prophase is that the nucleus, that nuclear membrane, it is dissolving. It breaks apart. All right. And this allows the chromosomes to kind of stretch out, right? It gives them more space. They're all contained in that DNA, all wound up in spiral circles. And what happens in prophase is that nuclear membrane breaks apart and the chromosomes can spread out. It allows them to become free floating in the cytoplasm. Okay. And the DNA, if you look at it in a normal cell, if this was not a dividing cell, the nucleus would look like this, right? You would not be able to see what you're seeing right here as these big, thick strands. All right, these big, thick strands are indicators of prophase. So if you have some of your Play-Doh, I want you to make a ball. All right, this is what your DNA is like in interphase. It's all wound up and contained in a nucleus, and that's what you see, a dense ball. In prophase, I want you to take your Play-Doh and make just some thicker strands. This is what your chromosomes look like in prophase. They're thick, chunky strands. You will need to be able to identify what these look like. You'll need to be able to explain the process, but you also need to be able to identify a cell in prophase, and these chunky little chromosomes in the nucleus are what are going to be indicators of prophase. Does that make sense? Prophase, I want you to think of these chunky little chromosomes. You should see these thicker pieces of chromosomes in prophase. In prophase, the nuclear membrane breaks down, the DNA can spread out, and then once it spreads out, it makes these almost little French fry looking pieces of DNA, and we call those chromosomes. Okay? We see these chromosomes. Let's move to the next phase. The next phase is called metaphase. Metaphase. All right? In metaphase, these chromosomes, all these pieces, they find their sister. Okay? So each chromosome has a sister chromosome, and they code for the same thing. Why would you have two chromosomes that code for eye color and two chromosomes that code for hair color and two chromosomes that code for what? Why? Yes, you're right, the table thingy. But why would you have two? Yes, Justin, right? So one of these is going to be the DNA that you get from your mom, and one of the DNA sets are going to be the sets that you get from your dad. So your DNA has unwound and chunked up into these chromosomes of corresponding DNA, right? So it finds its sister and they make this X. So make your chromosomes, find their sister, get your Play Doh, make your chromosomes form an X. They're like, oh, okay, where's the person for the size of my feet? Where is the person for height? Where's my sister? Have you seen my sister? The chromosomes are looking around for, oh, there you are. All right. And then they actually have something that holds them together at the center. It's called a centromere. Centromere. All right. It's kind of like a staple. It staples the sister chromatids together, and as they find their pair, they line up down the middle of the cell. So when you see the chromosomes lining up in the middle of the cell, right? I want you to think meta is middle. Metaphase is when the chromosomes line up at the middle. All right. Now, why would they have to find their sister? Like, why is that important anymore? Why do we care about that? What are we getting ready to make? DNA, right? So we need a copy of eye color genes in one cell. But what about this cell over here? Yeah, they need to each have all the information. Both cells need all of the information. So back here in interphase, all right, the DNA, let's go back to even this cell. What happens during part of their day is that your DNA actually duplicates. All right, your cell actually goes through a process of taking all the DNA and taking it to a copy machine and copying it. So that when we get over here, all right, to metaphase, we need to make sure that the copy and the original find each other, because what is about to happen in anaphase is that these pieces of DNA are going to be pulled apart again. All right. And so I say to think about that centromere as a staple or a paper clip because it's only temporary. It's not super glue. All right. Because in anaphase, we pull those copies apart because we're like, oh, the cell needs all this information in both the original cell, the OG, and the new cell. Does that make sense? Both cells needs all of the copies of all the information or else it won't work. So if you have Play-Doh, what I want you to do now is unattach them. That centromere and anaphase comes out. And they move apart. So if you see a cell where the DNA is like splitting to the sides, I like to think about Anna. Like Anna is like a little girl. Little Anna has pigtails, right? And the pigtails are pulled apart. It's the hair pulled apart from each other, right? If I put my hair on pigtails right now for you, it would look like this. It would be really cute. All right. It's pulling apart from the middle. Like, so from my middle part, my hair would be pulling apart to two different sections. All right. Anaphase is when those chromosomes are pulled apart. All right. Those chromosomes are pulled in two different directions and they're pulled by these little, can you guys see these little invisible lines? Do you see them? See these little, like, they're almost translucent lines? These are actually like little ropes. All right. They're like little ropes and they're called spindle fibers. And I kind of think of them like anchors on boats. And what they do is they attach to the chromosomes on each side, each sister, and they start pulling them apart. So the anchor is to each side of the cell, all right? And then those spindle fibers come out and they grab onto the sister chromatids and said, "Thank you, centromere," and pull those sister chromatids apart. Does that make sense? So an interphase are DNA copies. And prophase, our DNA is like, "Oh, I cannot get out of here." And prophase, the indicator is these chunky little chromosomes. We start seeing all those little chromosomes floating around. And prophase. And metaphase, they found their sister, long lost sister. Oh, there's my copy. And they're stapled together and they're put right at the middle. And in anaphase, those spindle fibers attach and say, "Come this way, please." Kind of like a line leader, right? Good. And that leads us to our last phase-ish, which is telophase. Telophase, all right? Telophase and cytokinesis. And so what you're going to see in telophase is that all of those chromosomes are going to be piled up on each end. Does that make sense? So here you see a cell in telophase. This is the original plant cell. All the chromosomes have been drugged to two sides. So these are the chromosomes. These are the chromosomes. All right. And a lot of times you'll see, what do you see right here? Kind of looks like a scar, right? The cytoplasm of the cells actually pinch off to create two. Yep, it's like it's a wall, it's a barrier that then pinches off to make two cells that are identical to one another. I wouldn't necessarily call it a wall. I would say it's kind of like a tracing line. All right. First of all, that line will come, you'll see that line, and it's kind of like cut here, like those papers like that you used to see have in kindergarten or whatever, where you cut out your shapes along the dotted line. It shows the cytoplasm where to pinch off. All right. So let's test our knowledge. What time is it? Let me check my time. 9:01. This is perfect. All right. We are going to do a scavenger hunt. Scavenger hunt. All right. This is what you may have to do in your end of course exams. You will have to be able to find these. So let's look for a cell in prophase. There's not a ton of these. Can you find a cell in prophase? I want you to use your little pointer fingers. Look for a cell in prophase. Yes. You're on it. Good. I want to see everybody. I want to see lots of pointer fingers. Even if you're pointing at the same one, that's okay. Find a cell in prophase. Prophase. You're totally fine. So these cells that you're pointing at with the big little chunks in the middle, all of these are going to be cells in prophase, right? There's one bubble and there's a lot of like little, you can see those thickened chromosomes right there hanging out in the middle. Good, prophase. What about metaphase? Metaphase in the middle. When the two chromosomes, they find their sister, oh, hi. And they come and they get stapled together to their copy. And they line up the middle of the cell. Good. Down the middle of the cell. Perfect. What about anaphase? All right, Anna, little girl Anna, they split from the middle. They're being pulled apart from the middle, and you start seeing them split. Yes, up here's a good example of one. Here's an example of one. You're seeing those, the chromosomes almost look at like they're V's being pulled apart. Right down here, you can see too, this is my red point. Actually, I'm going to use my thing. Down here, these are both in anaphase. These are both in anaphase. All right, this one is more in a, like the end of anaphase. This cell right here is the beginning of anaphase. They'd say like late anaphase and early anaphase. It's only one anaphase. And then this one down here would be early anaphase, where they just started pulling apart. Everybody see that? Does that make sense? All right, lastly, show me one that has telophase. Telophase. Show me a cell with telophase. A lot of telophase is looped together with cytokinesis, but I love in these drawings how, look how the DNA looks very similar in telophase as it does to prophase. See how they are? It looks very similar, but you have two of them. Does that make sense? Perfect. Yep, sorry, Ari, I didn't see that. The cytoplasm is going to pinch in at the middle, whether it be an animal cell or a plant cell, they'll both pinch in at that middle. Okay. I'm so proud of you guys. This is great. This is great. So I am going to end it here for today. This is mitosis. This is how a cell goes through cell division. All right. Just like you have processes for doing things in periods of your day, the cell does this too. Now, it is important to know this. I want you to spend time in this tonight. Why? Because we're going to learn about meiosis tomorrow. Meiosis. And can I tell you this? Meiosis. You have to know what happens in mitosis to understand meiosis. If you do not understand what we did today, you're going to have a really hard time tomorrow understanding meiosis. So I really want you to take this today. This is a very fun way to, a lesson to do drawings for. Do drawings. Get your markers out. Get your Play-Doh out. Get your slime out. Go get yourself. Can we answer the questions from this lesson? I'm confused. I'm so sorry. Which
I think he
question?
meant like from the lessons and the content, I think.
Is that what you're? How many cells are produced? Well, you started with one, and then how many do we end up after it pinches off? Yep. We start with one, and we get two cells. And are they the same, or are they different? We copied the DNA. We made sure each page of the document matched up, and then we split them after we made sure. So what does that tell us? Are they the same or different? If they all have the same information, they're the same. All right. So mitosis gives us two clones. All right. That's how you get all your skin cells right now. Your cells on your arm are going through mitosis. They're dividing. So Mrs. Rittenhouse can lose some skin cells right now, right? Because my other skin cells are going through mitosis and reproducing and making more. Just like when you get a cut in your arm, or maybe you've ran into the wall like I have and get a gash in your head and have to get stitches. The reason it heals is because your skin cells are going through mitosis and making new skin cells that are all that are the same. They match, right? And they're healing that spot with new cells. How many divisions occurred? Well, how many divisions occurred, guys? How many times did we go through telophase and cytokinesis? How many times did we divide? One time, right? Prophase, metaphase, anaphase, telophase, divide. So we went from 1 to 2. How many chromosomes are present in the daughter cells? We'll go over that tomorrow. It's specific to each organism, okay? But how many chromosomes are present in the daughter cells? It's the same number, right? So if this cell has 23, this has 23. And it happens in what we call our somatic cells, right? We have two types of cells. We have somatic cells and gametes. Okay, somatic cells are our body cells. They are not in our reproductive organs. All right, that is what we're going to talk about tomorrow. Because we know that those are special and have a different purpose. All right. Our gametes are our reproductive cells. They're only in one area of our body. There's only one division. Yep. One division. Mitosis is one division. Interphase, prophase, metaphase, telophase, or anaphase, telophase, divide. And that's it. One division. Yep, gametes. Gametes are going to be sperm cells and egg cells. That's it. Every other body cell type we have, any other type of body cell we have is a somatic cell. All right. And you take then all the information, you copy it, and you give the other cell all the information. Yep. Good. Any other questions? Does it happen in all your body cells outside of your sex organs? Your reproductive organs? Yep. If you don't have questions, you are dismissed. Like I said, make sure you're working on this outside of class, even though we don't have quizzes, because you're going to need to know this for tomorrow. Have a great day, guys. Bring some Play-Doh with you tomorrow if you can go get to the store and you don't have any, because we're going to use it tomorrow too. Bye, Ireland. Bye, Jasmine. Today is 3.24. Hold on a second, Mama. Looks great. 3.24. Yep. Thanks, Lily. Bye, Olivia. See ya, Opal.